Welcome, everybody. This video is CCBYCN. All right, well, today we're going to focus on double angle identities, and the whole scheme behind this is that we are assuming that angle A is the same as angle B. So when we take something like the sine of A plus B, and A is B, then what we're saying is the sine of A plus A, or the sine of 2A. And here's our double angle. And if we take our formula, we end up with sine of A cosine. Now, normally we would put B, but B is A in this case, plus the sine. Normally we would put B, but now we're going to put A, and cosine of A. So we get that the sine of 2A, notice these two are the same, is 2 sine A cosine B, cosine A, pardon me, A. So there is our first double angle identity. Now, cosine is going to be the same, but if you remember, cosine has quite a few different ways of looking at this. And I want us to recall real quick that we have sine squared A plus cosine squared A equals 1, but we can also rewrite this as sine squared A equals 1 minus cosine squared A, and cosine squared A is 1 minus sine squared A. So as we go to our double angle, and I'm going to, A is equal to B in this case, so cosine of 2A becomes cosine A, cosine, normally we would put B, but A is B in this case, and sine A, and again, we would normally put sine B, but because they're the same, we're here. You can see cosine times cosine is cosine squared, A minus sine squared. So cosine of 2A is cosine squared of A minus sine squared of A. But using our Pythagorean identity, if I replace cosine squared A with 1 minus sine squared A, we have that cosine of 2A is now 1 minus 2 times sine squared A. So we have two definitions so far. Now we're going to do a third. What if I'm here and I replace sine squared A with 1 minus cosine, we replace cosine squared A, sine squared A with 1 minus cosine squared A. We're going to end up with cosine squared A minus sine squared A, which is 1 minus cosine squared A. And you can see I'm going to get a minus 1 and 2 cosine squareds. So there we are. Tangent, the same thing is going to happen. It would normally be tangent A plus tangent B, but because A and B are the same, we end up with 2 tangent A's. And normally it's 1 minus tangent A times tangent B, but that just means tangent squared A. So here's our double angle identities. And you'll note we have 3 for cosine of 2A, and we use both. So let's start with our original example here. It looks like A, cosine squared of 40 degrees minus sine squared of 40 degrees. If I go here, that's just cosine of double that angle. This is going to be cosine of 80 degrees. B is going to be similar. Cosine squared of 7x minus sine squared of 7x. I'm just going to double that angle. This becomes cosine of 14x. Now for example 2, please note that cosine of x is 4 over 5. And again, I want to emphasize that's a positive 4 over 5. And cosine is positive in quadrants 1 and 4. Cosecant is negative or less than 0, same place that sine is. So that's going to be in quadrants 3 and 4. So we are, in fact, for this problem, we are in quadrant 4. So when we're building our triangle here, we have the adjacent is 4, 5, and this is our missing y. Y squared plus 4 squared equals 5 squared. We get y squared is equal to 9. And you know that y is negative in quadrant 4. So this is going to be y equals negative 3. Which means the sine of x is negative 3/5. And that's going to work out well for us with our new formulas. So sine of 2x is here. Cosine of 2x is here or here. Actually, we could use any of these. Then tangent of 2x. I'm going to do something a little different than that formula for tangent of 2x. So this means the sine of 2x is 2 times sine of x, which is negative 3/5, times cosine. Let's see if I can get all that in one shot. I can. So I'm doing 2 times sine cosine. Cosine is 4 over 5. That's going to be negative. 2 times 3 is 6. 6 times 4 is 24. And 5 times 5 is 25. There we are. No problem. Cosine of 2x. Again, I can make a choice, but I'm going to use the first one. Cosine squared. Cosine is 4/5 squared minus sine squared, which is negative 3/5 squared. I want to caution you to be careful. It looks like we have minus minus going on here, but we don't. We have to square that first, and then we subtract. And that's looking to me like that is 7 over 25. Now for tangent, I told you I was going to do something different than use the formula. You can use the formula. There's nothing wrong with that. But I'm going to say that the tangent of 2x is equal to the sine of 2x and the cosine of 2x. And the reason I'm doing this is because I already have sine and cosine. The 25s reduce out, and I end up with a negative 24 over 7. Our last, for example 3, it's definitely not our last. We have that the tangent is equal to negative 1/3. Now, tangent is negative in quadrants 2 and 4, and cosine is positive in quadrants 1 and 4. So once again, we are in quadrant 4. It's going to be important that you can identify that. Let's come up with our triangle. And if this is my angle here, then the opposite is going to be 1, and the adjacent is going to be 3. And in quadrant 4, y is negative, so that's a negative 1 there. And this means that our missing hypotenuse, which I'll call h, we can call it r, you can call it whatever you want, negative 1 squared plus 3 squared equals h squared. So 1 plus 9 is 10, so h is equal to root 10. This means that sine of x is equal to negative 1 over root 10, which is negative root 10 over 10. And cosine x is positive 3 over root 10, which is 3 root 10 over 10. And here we begin our double angles. So sine, I'll do here, sine of 2x is 2 times sine x, which is negative root 10 over 10, times 3 root 10 over 10. That's going to be negative overall. And that is going to be 2 times 3 is 6. Root 10 times root 10 is 10, so that's 60. Over it looks like 100, which reduces to negative 6 over 10, which reduces to negative 3 over 5. Next up, we have cosine of 2x. It's going to be cosine squared, so cosine. And I'm going to use this one, 3 over root 10 squared minus sine squared, that's negative 1 over root 10 squared, which gives me 9 over 10 minus 1 over 10, so that's 8 over 10, which reduces to 4 over 5. Tangent of 2x is going to be sine of 2x over cosine of 2x. So that is negative 3/5 over 4/5, and the 5's reduce. I get negative 3 over 4. So it's not too complicated. You just need to have the formulas. Next page. So now we're solving equations that involve a double angle. And I'm going to do two things for this equation. I have sine of 2x equals cosine of x. I'm actually going to get this equal to 0 by subtracting the cosine x to both sides. And I'm going to use a double angle formula for the sine of 2x. So that's going to become 2 sine x cosine x minus cosine x equals 0. And I'm going to note that I have a cosine x for both, so I'm going to factor that out. End up with 2 sine x minus 1 equals 0. And you can see if I add 1 and divide by 2, this is sine of x equals 1/2. So let's bust out the unit circle here. When is cosine equal to 0? There are two places that it's equal to 0. It is equal to 0 at pi over 2 and at 3 pi over 2. Sine is positive in quadrants 1 and 2. And when is the y-coordinate equal to 1/2? That's here at pi over 6. And that's over here at 5 pi over 6. All right. Example 5. Find all solutions to this here. Now, if you remember, we actually have several choices when it comes to the cosine of 2x. Cosine squared, sine squared, 1 minus 2 sine squared a, and 2 cosine squared a minus 1. Now, because I have a cosine function here, I'm going to stick to the one that has the cosine in it. That way they're all the same. And like I did with the previous problem, I'm going to subtract this cosine x to both sides. So cosine 2x becomes 2 cosine squared x minus 1 minus cosine x equals 0. And I'm going to rearrange that so it's a little bit easier to factor. So 2 cosine squared x minus cosine x minus 1 equals 0. So I just swap those two out. And now I'm going to factor it. And let's see, that's going to be minus there, plus there. That all equals 0. So 2 cosine x plus 1 equals 0. Cosine x minus 1 equals 0. So I'm going to subtract the 1 divided by 2. And add 1 here. So let's rewrite these up here. So cosine x equals negative 1/2. And cosine x equals 1. All right, cosine is negative in quadrants 3 and 4. And where's the x coordinate equal to negative 1/2? I'm up here at 2 pi over 3. And I'm down here at 4 pi over 3. So 2 pi over 3, 2 pi over 3, and 4 pi over 3. All right, and cosine is equal to 1. When is the x coordinate equal to a positive 1? That is at 0. All right, so here are our solutions. There are 3 in this case. Number 6 is a little tricky. What I'm going to do is we have sine of 2x minus cosine of 2x equals 1. What I'm going to do is I'm going to replace sine of 2x with its double angle. That's 2 sine x cosine x minus, and I've decided I'm going to subtract this one. And the reason I chose that one is I knew I would have to change the sign, and I want those 1s to go away. So I'm going to distribute the minus. And I'm going to notice when I subtract these 1s, they're gone. And what I'm left with is basically that. And I'm going to notice that I can factor out a 2 cosine x. So this one's a little weird because we have a sine and a cosine, but we'll handle that here in just a second. So 2 cosine x equals 0. Sine x minus cosine x equals 0. Here I'm going to divide the 2 out. Here I'm going to add the cosine x. Let's handle this one first, then we'll get to that one. When is cosine equal to 0? We have 2 places for that. We have pi over 2 and 3 pi over 2. Let me show you on the unit circle. When is the x coordinate 0? There and down here. That's pi over 2 and 3 pi over 2. Now this one is a little tricky. What I'm going to do is I'm going to divide both sides by the cosine of x. That is going to give me, bring this over here, sine over cosine is tangent of x equals cosine over cosine is 1. Tangent is positive in quadrants 1 and 3. And this is equal to 1, pi over 4, 5 pi over 4. So in this case, there are 4 solutions. Last two, we have 8 sine of 5x equals 2, and we want the smallest positive solution to 2 decimal places. Well, I can see right away, I'm going to have to divide out that 8. Which means the sine of 5x is 1/4. Well, the smallest is going to be in quadrant 1. And I'm going to make sure that I am in radian mode. You'll need to double check your calculator every time. And so I'm going to do inverse sine of 1 divided by 4. So what I have is I have that 5x is about equal to 0.25268. Which of course, what I need to do is divide that now by 5. So I can get x by itself. Divide by 5. Divide by 5. So now I'm going to take this and literally divide it by 5. I'm getting 0. It says round the answer to 2 decimal places, 0.05. For the last one, we're going to get the 2 smallest positive solutions. And I'm going to rewrite this as 2 sine x cosine x. And what I can do is I can move this to the right or this to the left, it doesn't matter. I'm going to move this that way. End up with 2 sine x cosine x minus 0.6 cosine x equals 0. They share a cosine x, so I'm going to factor that out. Cosine x times 2 sine x minus 0.6 equals 0, which means cosine x equals 0, and 2 sine x minus 0.6 equals 0. Cosine, once again, is 0 at pi over 2 and 3 pi over 2. Now I'm going to add the 0.6 and divide by 2. It's going to be 0.6 divided by 2, which is 0.3. The smallest angle is going to be in quadrant 1. So again, I'm going to verify that I'm in radian mode. And I'm going to go inverse sine of 0.3. That is going to give me that x is about 0.30, we'll say. Now they want the two smallest. 3 pi over 2 is definitely not one of the smallest. So this is definitely one of the smallest. That's in quadrant 1. And this is 90 degrees, or pi over 2. I hope that helps.